Hello, this is Mr. Steinerson, and in this quick video, I want to go over how Pivot Labs can help you with linearizing your data. Just a quick overview, linearization is a way that you can define what relationship your data has by looking at the graph. And so it might fall into one of these categories, either linear, parabolic, square root, inverse, or inverse squared. And you need to look at the shape of your graph that you're getting from your data to decide which of those fits is the best for your case. So I put in some data as a sample here, and this is completely made up data, not connected to any Pivot Lab whatsoever, but I have video game hours and then homework scores. And when I graph that, I put the homework score as the Y value and the video game as the X. And as I look at the shape of the graph, the first question I want to ask myself is which of these 5 types does it best match? So as I'm going down, I know it's not linear, so I'm not going to choose that. It's not really parabolic or square root, but it could be either inverse or inverse squared. So I'm going to start by looking at it as an inverse relationship first, and then we need to verify that it matches this according to the data that I have. That's the power of linearization. So in order to verify that it matches, I'm going to use the pivot data table, create a new column, and then perform the function of the inverse x values and regraph that. If I get a linear fit, I know I've done the right things, and then I can use that to find the relationship. So in Pivot, to add a column, you'll click on the 3 dots, do Insert Column to the right, and I'm just going to call this one Inverse for my x values. Okay, now I'm going to do exactly what I think the graph is telling me to, which is taking the inverse of all the x values. So in this case, the x values are the video game hours. To do that in bulk, I can use the built-in equation formulas in Pivot. So I'm going to do change column formula, and now I'm going to take 1 over, or the inverse, of the x values. My x values in this case are video game hours. Submit that, and it's going to calculate what that inverse would be for the x values. On my graph, in order to verify that this is a linear fit relationship, I have to change the x value on the graph to be what I want it to look like. I'm expecting it to be an inverse relationship, so I'm going to switch it to inverse and then hit done. Notice that now creates a linear fit. That tells me that I've done the right relationship. If this wasn't completely linear, I would go back to my values here and I would change it and I would do something else to those x values. Maybe I would do an inverse squared and try that and then see if that's a linear fit. And I would just keep going back and forth until I get the right fit. This looks awesome though, so I'm going to verify that by putting a linear fit on. So I'm going to curve fits and then linear. That verifies now that this is a linear fit, and it also tells me the slope. So notice here, my slope is 2.5 in that slope-intercept formula. So now I know the relationship. What I'm going to ask you to do is in the steps below where it goes to making sense of the relationship, here's where I want you to actually put in what the y value is. So instead of just typing y equals the mx plus b, I really want you to define what those y and what those x values are. So in this case, our y, if I look back on my graph, the y were the homework scores. So this is our relationship between those two things. So homework scores, sorry, my typing is not bad, scores is equal to, the slope from our line was 2.5 times the x values, which was 1 over the x was the video game hours, right? The time spent. So video game hours here. All right. So that's what I'd like you to do. Go back and redo that y equals mx equation to stand for your relationship, and then write a statement about how that's how that works. Thank you, and have a great day.